Ishiko realized he'd stumbled across a promising business opportunity. So he started conducting further research, mixing into resin a number of substances known to have insulating effects. He tried titanium white and mica, a substance that transfers little heat, even toilet paper cut into pieces. But he wasn't able to achieve the effect he was looking for. His mind went back to white paint, the source of his ideas, and he wondered if anything could exceed its heat reflection characteristics. Then he realized what such a substance might be.
When I was a kid, I often went out skiing. As it happened, there was a ski slope near the city where I grew up. The whitest thing that I have seen in all of my life is snow.
In the middle of winter, Ishiko got a sunburn while skiing. That's due as much to the snow as to the sunshine. Snow reflects 90% of sunlight, from ultraviolet to infrared.
I thought, if I could use a material like snow that's white to the human eye, but transparent under the microscope, maybe I could come up with something really great.
White but transparent, he found a material that satisfies that condition: perlite, a ceramic powder made of volcanic rock. Ishiko obtained some of the substance right away. He mixed it in the paint and tested it. Just as he expected, it reflected a great deal of heat. But the breakthrough that seemed so promising drizzled. Literally so. When applied to a wall or ceiling, it dripped. Ishiko thought he might be able to solve the problem by increasing the stickiness of the resin as much as paint would tolerate, but it still didn't work.
Because it dripped so much, I adjusted it so it wouldn't. But after time passed, it kept dripping and dripping. The weight of the ceramic powder was pulling it down.
A solution came by making hollow beads of the ceramic. Glass beads are used as reflective material for white road markings. Ishiko asked the manufacturer to make the same thing with ceramic. The turning point came 5 years after he repainted the factory, when he came up with an insulating resin suitable for sale. It didn't make much of a market impact at first, but revenue grew as word of mouth about the product expanded. The cooperation with JAXA began 4 years ago. The agency recognized the insulation technology Ishiko had developed on his own embodied the same concepts it used for its rockets.
I asked about the actual performance of his technology. He had already commercialized a product with technology that reached the level of our rocket insulating material. A few dozen micrometer hollow beads are used to create insulation. He'd already done it.
Just a year later, a new coating was developed that achieves high performance with 30% less thickness than conventional products. From houses to factories, it's been applied 5,000 times so far. A solution to overheating that is really cool.
One of the great things about this coating is that it's so easy to apply. It can be used in a variety of places. For example, they will paint an entire incinerator in a factory with it, so that if someone accidentally touches it, they don't get burned. Plus, when they go to fire it up again, the heat has been trapped inside, so it's more efficient.
They should put it on fry pans.
Well, no, fry pans are supposed to be hot. But that's not the only benefit. More recently, it's been working on the railroad.
Oh, the red long day.
Choo-choo!